Welcome again to this activity related to the team conference. And right now we have two amazing speakers in this session related to computational thinking. The session is coordinated by Francisco José García Peñalvo, and he will introduce the first speaker. So thank you very much.
Oh, yeah, Alicia. Well, welcome to this computational thinking track. This is the fifth edition of this track in Team Conference. Since the last year, we increased the scope of the track to introduce also robotics. Then the new title is computational thinking and robotics in education. We had 14 submissions, and finally we accepted nine papers. We are going to summarize so briefly the papers we received. I think you can see now my screen with a conceptual map. Then we have three main topics in the papers.
We only can see the EndNote or something like that. Yes.
Something like that. No? Then, right now?
Yes.
Yes.
Then we have three main topics, programming, computational thinking, and perhaps the main topic is robotics. Inside or within the robot topic, we have robots in museums, personalized learning with robots, low-cost robotic manipulators, and introducing robotics in emerging countries or in summer camps, or project related with STEAM, RoboSTEAM, and the problems with COVID, and also how to introduce robotics to learn programming. Regarding programming, we have a paper related to intelligent tutors in introductory programming courses. And regarding computational thinking, we have a paper related with, or trying to make a relationship between computational thinking and digital literacy. More or less the paper we have. If you go to the papers and video section of the website, you have the different videos, and after the conference, you will have access to the all full papers in the proceedings. Then this session is organized with two keynote speakers with two webinars. The first one is presented by Miguel Ángel Conde from the University of León, and is entitled Software Simulation Framework for Education and Robotics, and is related to the RoboSTEAM project. More or less 20 minutes, 25 minutes, just in order to make a break, and the people that is following us in YouTube can make some questions. And after that, Juan David Rodríguez García will present the project Learning ML. Then, Miguel, the floor is yours. When you want, you can share your screen and start your webinar.
Okay, thank you very much, Fran. Thank you very much, Alicia. And thank you all of you for being there in so much difficult situation as we have now, and in so strange way to carry out the conference. That is not the usual one, but we are very happy to be with you anyway. Okay, I'm here today to talk about SAFER. SAFER is a simulation framework for education in robotics, and it's related with my university, University of León, with my group, that is robotics research groups, and with the RoboSTEAM project, because we are applying it there now that we have the problem of COVID. The presentation follows the following topics or following outline. First, an introduction about what we are talking about. What is a remote lab? Why to use them in different contexts. Later, we will talk about SAFER. And later, we will comment how we are applying SAFER in RoboSTEM project. Later, after that, we share with you some demos about how we are using it for teaching robotics and also for teaching other kind of courses. And finally, we can discuss, if you want, about the possibilities that this kind of simulator or this kind of remote lab provides us. Okay. First of all, we have to think that we live in the context of the digital society, and technology has had a very important impact in our lives. Is having even. The problem is that maybe this technology is not having so much important impact in education, because some people is also continue working in teaching and learning in the same way. But the thing is that we have a lot of tools, a wide choice of tools to apply in our teaching and learning activities. Taking this into account, we have possibilities to deal with online learning in a proper way, and also to be able to overcome situations such as COVID situation that we have currently. Between these tools, one of the most relevant probably that all of you can know is a learning management system. Learning management systems are places where students are teaching and teachers can interact during the teaching and learning activity. We have to think that most of the universities, most of the schools have a learning management system, probably not always used in the same way, because as you know, it depends on if you are doing online classes, or it depends on if you are doing, or you are carrying out activities that only implies to read contents. But you have a lot of possibilities. You have the possibility to work in workshops. You have the possibility to see videos, to download contents, to make sums in different ways. It's a very powerful tool, a very powerful platform. This is for the student and for the teacher also, because they have a place where they can focalize most of their contents, resources, carry out the activities, etc. And this is very well, and most of the people is happy. But what happens when we have something such as a lab, where the practical issue is part of the nature of the lab, that you need to interact with the things that you have on the lab? How we can deal with this? In this sense, we have to consider that in a lab we can have PCs, we can have pipes, we can have some other kind of material. It's not the usual thing that we have at home or that we have in our normal classes. So it's different, and it's something that is more related with face-to-face teaching and learning. Okay, the students and teachers should interact face-to-face in order to fulfill this kind of knowledge transmissions that take place between them. In fact, lab has several issues. Normally, they are equipped with excellent material, but it's a very specific, a very expensive material that is difficult to reproduce in other contexts. So it's a very concrete, very specific place. In addition, many labs are overcrowded. We have not so much, many universities, we have not so much labs as we would like. We would like to have more, so all people could interact with some contents, with the elements, but this is not the usual thing. We used to be overcrowded and under-equipped because the budget constraints that we have at the universities. In addition, lab classes usually require direct supervision and feedback for the teacher, because it's the only way in which the individual is going to learn. And it's something that requires to be there. Okay, and in addition, it's something necessary, because sometimes if you do not manage properly the instruments that you have in a lab, you can have a problem, because you can break it, and it's very expensive. So we need to supervise these kind of things. given the situation, a good idea could be to be able to simulate this kind of labs, okay, to simulate this kind of labs, but not only simulate a specific lab, but provide frameworks that support the simulation of any kind of lab in any kind of situation, which is really, really interesting. In addition, we are in the current pandemic situation, and this means that we have to go, or we had to go home during some times, and we cannot stop education. We need to continue, and the way to continue education is to providing the students with the tools and with the contents that they need to learn. So how we are going to deal with labs if we are not using simulators, cloud remote labs, etc.? We need something to do this. And in this context, the robotics group of the University of León, and in the context of a startup that we have created at León, SAFER was built. Okay, SAFER, as I commented before, is a simulator framework for robotics in education. Although it also tries to reflect the name, the suffering that we have all when teaching with students, and especially in this very difficult situation. So what we have tried to do with SAFER to reduce this suffering? Well, we have done an architecture based on cloud, okay? Based on cloud, but that allows to work from different cloud perspectives. One is containers as a service, as you can see on the screen, where you can manage the containers, the operative system, the virtualization, hardware, etc. And you can, as a teacher, to define the middleware that you want to use, the data that you want to access to, and the applications that are going to be available for students. We have also the possibility to work in a model of platform as a service. And in this case, it's the same, but in this case, the middleware was going to be set up. Okay, so the only interactions will be with the data and the applications. And we can work as a software as a service, just providing the students something they can use during their learning. On the bottom side of the screen, you have the other representation simulating a robotics lab, where we have as container as a service, the middleware that we have defined, the middleware that we are going to use is ROS and RobotComp. The robot that in this case is going to be the container, if you want to say it, and application and data that we are going to use with the robot. So we are going to provide each student a virtual robot in which he or she can interact, and they can program and they can work with it. Okay, so that's an interesting idea. Another possibility, more near to maybe programming and things like that, we are applying it in operating system and in programming, is to provide the students with machines completely set up. So the only thing they need to do is to work in them. And the possibility that this kind of remote labs provide is that the students can work together or alone in a machine, and that the teacher can go into that machine and interact with them and see what they have done or try to help them to solve their problems. In this way, we are providing them feedback that is really, really important in order to ensure the success of this kind of lab works. In addition, and also very important, is the monitorization part. Okay, we have the possibility to monitorize different issues related with the container, with the platform, with the application, or with the data. Here you can see some information about the container. Okay, the container use memory usage, the node traffic, the memory, etc. We can have individual information related with each of the machines that we have up and running. Okay, and we have also the possibility to know how students are using these kind of machines. This is just a sample. We can consider the container, but we can consider the logs that they are providing into the containers, such as how many time they are spending in something, how they are working with it, which are the main problems, etc. So we have also this possibility. And in addition, we have the possibility to apply different monitoring techniques to show specific issues or to try to exploit specific issues defined for some different applications. Having this context and having described the SAFER framework, I'm going to talk about how we applied it in a project. In this case, it's our STEAM project. Our STEAM project is an Erasmus Plus project, strategic partnership that try to define some methodology and a set of tools to help learners to develop computational thinking by using robotics and physical devices. The project involves exchanges between students, and we have schools, we have universities, and we are working on dealing with this kind of issues related with robotics. In fact, one of the most important things is that we are applying challenge-based learning approaches in order to allow the students learn and exchange knowledge between them. The partners involved are the University of León, that is the coordinator, University of Salamanca, University of Stirling, the Instituto Politécnico de Bragança, Colegio Internato dos Carvalhos, IESRAS de Renueva, Agrupamiento de Escuelas Emilio García, and Karlsruhe Institute of Technology. We are working together in order to provide a better way to solve challenges and develop computational thinking by using robotics and physical devices. Here you have some of the results that we have obtained during our exchanges. During this project, we have exchanges between students from different socioeconomic contexts, for instance, from Finland to Portugal or to Spain. And they have tried to solve or to address challenges or many challenges in order to see how this work with the challenge-based learning approaches and with the use of robotics. In addition, we are including people from arts, and as you can see, we have very beautiful representations of the scenarios where our robots or our physical devices are going to work. The problem is that COVID arrives. COVID arrived on March, and we have to stop exchanging. And some also of the piloting should be, I don't know, slowed down, if you want. This means that we need to look for other ways to deal with the idea of using pilots, the idea of collaborating between students, the idea of working with robots. And in this case, it's a necessity to move to online solutions. And to move to online solutions, a good idea could be SAFER, because it allows us to define a set of machines where we can define or develop any kind of machine, any kind of robot, and later allow the students to work with that robots and to try to program them. Now, once we have this, so I'm going to show you how SAFER is working, okay? So give me one second. I'm going to open I'm going to share, wait a second, I'm going to share with you my other screen in order that you can see how the simulator is working, okay? Give me 1 second. Okay. Okay, I'm changing the screen. I don't know, where's my mouse? Okay, now I have it. Okay, I'm going to show you, I'm showing you now, or I supposed to be showing you my simulator, okay? This simulator that you should be seeing now is one simulator that was created for the use in our robot labs. I am going to connect, okay? Wait a second, I need to check my password. Okay. And as you can see now, I'm connected to a machine that is representing the infrastructure of a ROS and a robot, in this case a Turtlebot. Turtleout is a type of robot. In a next scenario that you can see on the left part of the screen, you can see something where I have my mouse now, that is the robot, okay? And you can move the robot, you can program the robot and look for ways to interact with it. I'm going to show how the robot is moved. It can be moved, okay? So give me 1 second, I'm trying to move it now. Okay. I don't know why it has stopped now, but well, probably, okay, it's moving now. You can see the robot moving now in this scenario, and it is also generating us data, and we can check it and we can study it, and we can try to program the robot in order to avoid obstacles or whatever, that to try to solve one navigation problem that is related with any kind of robots. Okay, so it's interesting because you don't need to have the Turtlebot, you don't need to have the scenario, and you can do this at your home. And the teacher can go into your simulation and tell you what is right or what is wrong. Okay, this is a possibility. We have other possibilities. So now again, I'm going to open another possible way to do this. That is this one. I hope you can see my screen. I have no feedback, no direct feedback, so
we can see.
Okay, okay. So now I'm in the one way we are using at class, okay, in operating system and in programming classes. And here I have my machine, that is Conde, and the other are for students. The students could have a single machine that they can be using during all their classes, during all the semester, but also they can have specific machines for the specific lab classes. Well, what is the idea in this case? In this case is to being able to help them or solve their doubts independently of being there in a physical way, or even you can be there in a physical way, but you have not the possibility to be near to them because we have to maintain the social distance. Okay, so I can go to my machine, and I think it's a bit today is slower than other days, but the idea is I can go. Okay, I'm in one of my students' machine now, and I can control and I can see what they have done. Okay, so I can also take. Tell them, okay, you have this right or wrong, or I am going to help you to solve this. This is just an Ubuntu simulation. So in this case, we are using it as platform as a service, but it's very useful for the students to work with these kind of solutions. Okay, I'm going to return to my presentation again. So give me 1 second. Okay. Okay, I'm here. Okay, with again with the presentation, and well, once we have seen this, the idea is to continue working on it. We are now working on the idea to produce flexible labs. The idea is that we are not providing a specific lab for something. We are providing we have the possibility to tell a teacher, okay, what do you want to install? What do you want to use? Do you want to use some things with some students and some other with others? Do you want that the students work together in the same machine in order to obtain a results? Do you want to help them? Do you want just to see what they are doing? The idea is to work in the specific same way that you will be working at home, at class. And you can use it in a robotics context, but you can also use in a normal class, which is very, very interesting, specifically in the COVID situation that we are now, because I have problems with my students, and I can go to a computer when they are telling me this is not working. Okay, I told them, okay, open your virtual machine and show it to me. I will go to your virtual machine and I will see what you are doing wrong, and I'll try to help you. Okay, now what we are working on is on managing the possibility to provide the teachers with knowledge and with permissions to build their own machines, to put up or down some machines depending on the moment or the situations. So maintenance of the robotic simulators was not so hard, okay? But because it's not easy sometimes to deal with this kind of simulators. So we are currently working on it, and we are also currently working in different kind of monitoring that is very interesting. Finally, we are trying to work and we are trying to improve the integration of communication with students, because now the communication is not through any tool. So we have provided them with we have not a video conference tool integrated into the remote lab, but we can add it, and we are looking for the best ways in order to do this. Okay, so that's all. I don't know if you have any doubt, any problem. I hope to be in the schedule, so I'm now open to questions or suggestions or whatever you need.
Thank you, Miguel, for your webinar, for your presentation. Miguel can't stay with us till the end of the session. Then we are going to open a small space for questions. Then if anyone wants to make a question in YouTube, please do in the chat and I will translate it to Miguel. Meanwhile, if I want to know your opinion about one issue I see in this simulator, because well, we are living in a very complicated situation. This is the plan B of our work plans in the European Union. But in your case, you have a project that is related with physical devices, is related with robots, and the activities are planned to be done in the schools. What about the acceptation of the younger people of these kind of simulators and the feeling in order to make the challenge you propose?
Well, with the information that we have right now, feeling at the university students from university students is very good, because they have not to install nothing. This is useful for them and it's working well. Regarding with students of schools, we have only some feedback. It's not too much, but the idea is that for them it's easy to work with this, and for them it's possible to work with their peers in project, which is not the usual thing. In which other way are you going to work with robots together in an online situation? The problem is that probably they can work in a Google Forms but how are you going to deal with the solution of challenges and the solution of other kind of problems if it is not with this kind of tools? Students are happy. Maybe teachers are more resistant to change and they need information about how this is working, but we are dealing with it and we are trying to help them, support them, and provide them guides in order to work with this. But well, I hope to have more information at the end of the project when we are going to have more data about the students and about the teachers, and we are also going to have objective information regarding the things that we can obtain from the lab. Okay.
Thank you, Miguel. We have no question in YouTube. Then we are going to pass to the next keynote. That is Juan David Rodriguez, that is going to present us a very interesting project or initiative to teach or introduce machine learning in the schools. Then, Juan David, thank you so much to be here, and the floor is yours. One moment, Juan David, because you have the microphone mute.
Yes, okay. Thank you very much for the presentation. I'm going to start. Well, I cannot to put the how do you say in English, the fondo.
The background.
The background. I have some problem with my computer, and well, this is the background I have. I hope there is not a problem. So I'm going to start with the presentation. First, I'm going to share my screen. Okay, here. share, and the presentation is there. Okay. So, okay, well, I'm Juan David Rodriguez. I'm a secondary education teacher and software developer. But since 2007, I have been working at INTEF, which stands for Spain National Institute of Educational Technology and Teacher Training. Well, in this talk, I'm going to present Learning ML, which is a project I am developing with the collaboration of some member of KGBL3 research group, Dr. Jesus Moreno, Marcos Roman, and Gregorio Robles, which is intended to teach and learn AI fundamentals to kids through hands-on activities. So in this talk, we'll start by giving some reason to teach AI at the school. Next, I'm going to present a little introduction to machine learning. And next, I'm going to show the platform Learning ML. And last, I'm going to talk about the research we are doing around the platform Learning ML. And if I have some time, I hope to perform a live demo of the tool. Okay, so let's start with the first point, some reasons to teach AI at the school. Okay, so we think that in a society highly dependent on digital technology, teaching the fundamentals of computer science is a great strategy to help citizens learn these technologies. Indeed, almost every country in the world has included in some way programming and robotics content in the school. In this sense, artificial intelligence is one of the last computer science disciplines that is having a great impact in our society. Even though a lot of people are thinking that AI is a matter of science fiction novels or something exclusive of universities, research centers, and big computer corporations, the reality is very different. Indeed, we are all using daily, more or less consciously, applications based on artificial intelligence. Let's see some examples of them. For example, facial recognition, spamming filters, conventional chatbots, conversational chatbots, computer playing, self-driving cars, products recommendation system, sentiment analysis, language translation and recognition, and many more are based on AI. And all of these technologies are being used daily by millions of people. So the point is that AI is having a strong impact on all aspects of society, from economics to education, and will have even more impact on the future. It's a must, therefore, that citizens know its fundamentals in order to understand what can be made with AI and how it can affect our life. The ethical side of this technology is an issue that should concern all of us. And in this sense, we arrive at the second reason. In this sense, as a consequence, AI is a priority in the agendas of institutions and governments around the world. In this slide, I show two reports about the impact of AI in education. The first one, which has been developed by the Joint Research Group of European Commission, and the second one by UNESCO. In both reports, foresees that AI will change learning, teaching, and education in the next few years. And we arrive to the third reason, which is a consequence of the previous one. The third reason is the hand-on AI activities, practical activities about AI can be added to programming and unplugged activities as a new and powerful instrument to foster computational thinking. In this sense, some new concepts, practice, and perspectives coming from AI can be added as new dimension to the classical Brennan-Resnick computer thinking framework. This has been proposed by Jessica van Brummelen and others. The classification, prediction, and generation have been proposed as concepts, training, validating, and testing as new practice, and evaluating as a new perspective. So these are three reasons we think artificial intelligence content must be taught at the school. So we arrive to the second point. Let's present a little introduction to machine learning. Okay, well, the first thing we have to clarify is that AI is more than ML. ML is a subfield of artificial intelligence. And a good way to illustrate this fact is by means of this drawing, which summarizes the artificial intelligence field into 5 big ideas. First, computers perceive the world using sensors. Second, agents maintain representations of the world and use them for reasoning. Third, computers can learn from data. Fourth, intelligent agents require many kinds of knowledge to interact naturally with humans. And the last one, but probably the most important, is that AI can impact society in both positive and negative ways. As you can see, one of the big ideas is that computer can learn from data, and here is where machine learning comes into play. Machine learning encompasses a range of techniques that allow computer to learn from data. Most of the current AI development is being carried out with machine learning, so it's very frequent to say artificial intelligence when we really want to say machine learning. Okay, so what is machine learning? Well, we can solve a lot of problems by coding in a traditional way. We look for the rules underlying the problem, and then we implement them in a computer program. We use some kind of language, and we code the rules we have extracted by analyzing the problem. Okay, however, there are some problems which are really difficult to solve in this way because we are not able to find the rules. Then, this is the key, when we don't have an algorithm able to be applied to our problem, but instead we have lots of data related with the solution, we can deal with the problem from another perspective. We can use this data to infer possible solutions. And this is the essence of machine learning. Let's see this idea with an example. Let's consider that we want to recognize what digit corresponds to the number written by hand by different people, taking into account that the same digit has a similar but different shape depending on the people who write it. To find a set of rules able to solve this problem is a very difficult task. So how can we deal with this problem with machine learning? Well, first, we can gather a big set of examples taken from several people and tag each handwritten number. We put a label to each handwritten number with the corresponding digit. And this way, we build what is called a training dataset. Afterward, we use this labeled dataset to feed a machine learning algorithm that will use the data to fit a model able to classify new handwriting numbers. In this picture, you can see the model that is represented by the machine, while the genius represents the algorithm that is working hard to adjust the model parameter and to build a model which is able to classify similar, although different handwriting numbers. As an analogy, we can say that the computer is learning from data. Okay. But the algorithm, the real task of the algorithm is to build this model. Once the machine learning algorithm has finished, the model is available and we can use it in our application. We can introduce a new handwriting number as input, and the model gives us as output the corresponding digit and also a percentage representing the confidence of being correct. Since these are probabilistic models, they assign a probability to each of the possible answers. Okay, so the matter is that we can talk about a new way to solve computing problems. In this slide, the top box shows the traditional programming way, while the bottom box illustrates the way problems are solved with machine learning. It is important to realize that once we have the rules, once the machine learning algorithm has given us the model with the rules, we can use these rules, this model, to make a program in the traditional way. And here, I would like to point out that the bottom box provides us a new way to work and develop computational thinking skills. And it makes possible to introduce the new concepts, practice, and perspectives that I said earlier in this talk. Okay, so to finish this section, I would like to point out that what I have shown is known as supervised machine learning, but there are more types of machine learning. Anyway, beyond details among these types, the main idea is that all of them are based on data. That is, data is the key. Well, okay, this is very beautiful. It sounds great, but can we really teach AI and ML at the school? Well, we think that with our platform, Learning ML, we can do it. Well, what is Learning ML? Learning ML is a platform which is intended to teach and learn ML by doing. It has been designed on the principle of low floor, high ceiling, and wide walls. That is, it must be easy enough to start with. This is low floor. It must allow people to do better things. This is high ceiling. And finally, it must support different interests and be used in different situations. That is wide wall. These principles have been used when developing successful programming platforms such as Scratch, for example, the most known, and Snap. Therefore, we have also taken them to develop our tool. The code of the application has been released with a free license and a new free license, free as in freedom. So anyone who wants to study it or modify or contribute can do it. And also there is an instance of the application which is free. Free as in gratis, accessible. This platform is accessible through the URL https learningml.org. Okay, the tool has been designed to be used for children in the age 10-16, but we think that it can be a good tool also for undergraduate students and professionals who must or want to understand machine learning fundamentals due, for example, to the new tools based on this technology that are being introduced in their fields. Also, anyone who wants to learn the fundamentals of machine learning in an easy and funny way can enjoy the tool for sure. Our main goal has been to build a tool very, very easy to use. In this sense, you don't have to install anything in your computer since it is a web application running in the browser, and also registering is not required. This speeds up the time needed to try and make something useful with the tool. However, if you want to use some extra functionality, such as saving projects in the cloud or sharing them with other users, you can register at any moment and create an account on Learning ML platform. In addition, the tool has not any dependencies on external AI service, so it is completely autonomous. Well, the platform is composed by 3 parts. The first one is a website where you can find documentation, activities, video tutorials, and other resources to learn ML and AI. The second part, which is the machine learning editor, it is the most important component of the platform. You will use this component in order to build text and images machine learning recognition models. And finally, we have a programming platform where you can code a video game or application that use the model built with the machine learning editor. And this is a modified version of Scratch. It's a fork where we have added some new blocks intended to make use of the model you have built with the machine learning editor. Okay. So if you are interested in knowing more about this platform, you can read this article where we describe in depth the platform Learning ML. Okay, so we arrived to the last point, the last section. I'm going to present some research we have done with learning or around Learning ML platform. Well, here. Until now, we have written 3 papers about the topic. 2 of them have been published, and the third have been accepted in SIGSE, which stands for Special Interest Group on Computer Science Education, in the Technical Symposium of the year 21. In the first one, we talked about the experience we had got when developing an educational resource on artificial intelligence and machine learning with Machine Learning for Kids at INTEF. Machine Learning for Kids, it's a platform developed by Dave Lane from IBM, and it's perhaps the pioneer platform which is intended to learn machine learning fundamentals to kids, and it has been the inspiration for our own tool. Our purpose has been to simplify the tool and to make it easier even than machine learning for kids. Okay, in the second, okay, sorry. Okay. In the second paper, we have described tool Learning ML in depth, and we show some preliminary results obtained in a workshop about AI with a small sample of 14 participants in the age about 20. Well, it's typical researching. They filled a pre-test, then an introduction about AI, which include the use of Learning ML was performed, and finally the test was filled again. Then the answers were statistically analyzed, and 2 kinds of questions were asked. In both cases, we found a positive effect size. The next step, which has been carried out in our last work, in this research, we intend to test the instructional and phase validity of the tool. So we want to know if people learn AI when using Learning ML, and if they find the tool enough engaging and easy to use. So in order to do that, as we cannot organize a face-to-face event because of the current pandemic situation, we planned an alternative online workshop, which was carried out in June. Here it is scheduled. And first, we promote the research on social media in order to recruit volunteers, teachers, fathers, and mothers interested in collaborating with their students and children. Then we presented the initiative in a live seminar where such collaboration was asked for. Among the volunteers, a set of unique numerical codes were distributed in order to assign to their student. In this way, we can identify the answer, keeping the anonymity of the children. In every moment, we gave instruction to the teachers and fathers and mothers about how to proceed with their students. Summarizing, first the student had to fill up a test. Afterward, they watched a live seminar where an introduction to AI was given and the Learning ML tool was presented. And next, they played with Learning ML by doing a practical activity. And lastly, they filled a post-test. So the results, this slide shows the summarized the participation in the initiative. You can see 63 teachers were registered in the research, and they contribute with a total of 494 students. 469 of them completed the pretest, 162 completed both pretest and post-test, and finally, after cleaning the data, 135 subjects were valid, which is a good number to extract statistical conclusions. You can see that 47 were primary students, while 88 secondary, 108 had some programming experience, while 27 not. 66 were boys, while 55 girls, and 4 did not want to say the gender. Well, this last proportion shows clearly the gender gap existing in the technical world. Okay, so the results, summarizing the results of the research, we have found that students improve their score in the AI test that we have designed, and that they perceive Learning ML as a tool easy to use and useful to learn AI content. Also, we have found that there is no significant difference between students with and without previous programming experience, which supports a very interesting idea, which has been proposed by Judy Long and Brian Magetto in an article entitled "What is AI Literacy? Competencies and Design Consideration." So, as I said, the idea is that AI literacy and code literacy are independent. And this idea, which is given, as I said in this article, well, is reproduced experimentally in our results. Okay, so in addition to this, we have performed a test network analysis with the tool Infranodus over the answer given by the student to the question, what is AI? This was a question we asked for both in the pretest and in the post-test. So this kind of analysis reveals cluster of terms which are relevant in the set of tests we are analyzing. And we have found that before the intervention, the word robot is one of the main terms used by kids in their definition of AI, while after the intervention, this word disappears and solve and problem become the main terms. What this shows is a clear shift from the ideal image offered by the media about AI toward the most real image about what AI really is. That is, a set of computer techniques which help us to solve problems. Okay, so I will finish the presentation by showing the tool in life. Okay, sorry. Okay. Well, here is the ML editor. You can, it's translated to several languages. in this editor, you can choose between to create a test model or our image recognition model. I'm going to show this, I'm going to do this demo with the image model. Well, here are the 3 steps or 3 phases of supervised machine learning. The first is to train, that is to gather some images. So I'm going to create some classes. The first class is named face. The second class with glasses. And I'm going to name the third class with cap. Okay, then now what I'm going to do now is to take some pictures of myself by wearing a cap. Then these pictures, well, I click on the camera button, and now I'm going to take some picture of myself wearing a cap. Okay, I will move my head a little bit in order to take different images, similar but different images. For example, 15 images works fine, are enough. Now I'm going to do the same, but by wearing my sunglasses. Okay, again, I move a little bit my head in order to have different images. And finally, I'm going to take some pictures of myself without any complement. Again, different, okay, more or less about 15 images in each class. That is our data set. That this is our set of data labeled, which they will be used in order to feed the machine learning algorithm. Now the GNews is working by adjusting the parameters of a model, and in order to build a model able to recognize myself by wearing cap, glass, or nothing, and even in different situations. This is a process which takes lasts a while, and once finished, we have a model which can be used in external application. But before use it in an external application, I'm going to test it. This is the third step of the supervised machine learning technique. I'm going now to take a photo of myself, and the model will give the class he think the image belongs. Okay, say that this is the class face with a 66% of probability. Now, if I wear my hat, my cap, again, I can move, and the model says that it's me with a cap, and the same with glass. Okay, again, the model works fine. Well, once we have the model working fine, probably in some cases the model don't work enough well. So we have to add more data to the data set to retrain, that is, to run again the machine learning algorithms until we reach to a model which is enough performant, which works well. In this case, it works well, and now what I am going to do is a program in Scratch which uses this model. I click in the button in the cat, and the fork, our version of Scratch, is loading. as you can see, this is a Scratch where this is Scratch, but in our machines is another instance of Scratch, although it seems totally similar because it is Scratch, but we have added these blocks. These blocks are intended to use the model we have just built. I'm going to load a simple and very easy program I have built for this presentation. Is an imitator. The idea is that, well, I'm going to put this in English. Okay. The idea is that I have 3 costumes for this actor, for this object. The first is named Face, the second is named with glasses, and the third with cap. You can see that are the same names I have used in order to label our dataset, my dataset. So now the code use only just 2 blocks. The first one is to turn on the video, and the third is to classify the image that coming from the video image. Then the classification of this image that comes from the video will be used to switch the costume to one of these costumes, that is, to one of face with glass or with cap. This is running in a infinite loops, and well, the result is the following. I run the program. Okay, then you can see the cat don't wear any complement, but now I'm going to put my cap and the cat do the same as me. And I put the glasses, take the glasses, put my glasses, and well, he imitates everything I do. And well, this is the presentation here, as a quick presentation, but you can have an idea about how the platform works. And well, that is all. I hope you have enjoyed, and thank you very much.
Thank you so much for your presentation. It's so interesting, I think, and very practical to see, and trying to imagine how is carried on in the schools. We have a couple of questions. The first question is the current machine learning tools for under 12 or K-12 level or schools have an emphasis in supervised learning. How you will approach with unsupervised learning in similar settings?
Okay, well, this is something I haven't started yet. I would like to do it, but well, right now, as you have said, every tool intended to learn machine learning in a practical way is focused on supervised machine learning. However, there are other approaches by other researchers and teachers which deals with the unsupervised machine learning and the reinforcement machine learning, but by coding directly on a programming platform. Even in Scratch, there are some works in which the student compose a neural network or compose some machine learning algorithms, simplified, of course, as random trees or like that. In my case, I haven't thought yet how to attack this problem, because really they are different, very different. The good thing with the supervised machine learning approach is that he has a standard frame which is composed by 3 steps, and these steps are very easy to show in a practical, in a visual way. I think it's clear that for this reason, almost no, every application intended to do this use supervised machine learning. If we want to deal with unsupervised and reinforcement, we have to introduce in the own algorithm, and the algorithm is not easy to explain because it requires some mathematical knowledge. In this case, in supervised, as you can see, we haven't found the algorithm. We found the frame of the supervision process. We take a lot of data, we train the algorithm, but it's a black box for us, and we have a model which we can use in a application. So the intention is that kids or that people can generate some intuition about the procedure of build model from data. But well, summarizing, I haven't thought yet how to deal with the other two kind of machine learning.
Thank you. Another question: is it your homemade learning method behind the system, or you are using, as for example, TensorFlow?
I am using TensorFlow, but TensorFlow JS, that is in the browser. In order to the server is not used; it's used just for save your work in the cloud or to share some project. Indeed, in the demonstration, you can see that I'm not logged. And you can use without registration. So every algorithm is run inside the browser. And in order to do that, I have used 2 libraries. For the image, I have used TensorFlow, the version for JavaScript. And for the text recognition, I have used library which is even easier than TensorFlow. It's less powerful, but works very fine, and is known brain.js.
Okay, another question. Do you think it will be possible to use this platform to analyze code written by students?
I don't know. It will be a very experiment. I have to try, or anyone who are interested on it can try it. I don't know how to focus the problem. I think probably if this code is Python, this code is JavaScript. In this sense, I think it will be work, but in order to recognize different styles of programming, well, I'm not sure, but well, this is a platform you can to try different ideas, and well, there are ideas that will work, and another probably will doesn't work.
Okay. Well, thank you, Juan David, for your presentation, for your webinar, to be here with us in Team Conference. We are a little bit out of the schedule we had, but it was very interesting, and thank you so much to the people that are following us in the YouTube session. And this is all for this session, and we will continue this afternoon. Thank you so much, and goodbye to everyone.
Okay, thank you very much. Bye. Thank you.
Muy interesante, queda muy chulo, ¿eh?
Estamos fuera ahora, ¿no?
Sí, creo que estamos... Bueno, sí, ahora
Uy,
bueno, todavía
me despeinado un poco con la gorra.